Good morning, everybody. I just thought I'd make the first one, the 1.1 video. So I'll show you how it works. The 1.1 is just intro to stats. I'll show you a couple ways to access it and kind of what I'm expecting. So let's share the screen and get started. So if we go to your modules, you will see that the first one that we have to do is 1.1. And we have 1 through 3, 6, 21 through 24, 37, 38, 40, and 41. We have to submit a file, Word, Excel, write on a piece of paper, scan it in, however it works for you. Okay, so the first thing we're going to do is go to My Lab and Mastering. And I'm going to go to, just going to open it. Sorry about all the tabs. Oh, and one other thing, if you get really stumped, they pay for free tutoring, which is super nice. So if you go to BrainFuse, it's like free tutoring. Isn't that cool? And it's also for English. So here we go. I'm gonna go to the first one, which is eText, Introduction to Stats. Now there's videos too you can watch, which is cool. It's got assignments, but your work is in study plan. So if you want to go through that, your work is going to be in the study plan, which is nice. And these will be all the questions you have. Now, this is kind of weird to navigate, so I never do it this way. I just wanted to give you another option. So if you click this, the good thing about it, it tells you if you're right or wrong. Like these are all the questions, which is kind of nice. Throw right here. And we can just be like right or wrong by clicking this answer choice. So we'll leave that just as an option. But if we go to just eText itself and open eText, oh, I did that fast, sorry. Pearson eText, boom, click it. The book will open. And I'll give you some stuff about 1.1, just some basic information before we get there. We could also use Finder for stuff, which is cool. So we're in 1.1. It's you can zoom in. It's talking about critical thinking, sampling, source and data, some basic information that you need. Good idea is that a population is every possible person that you can ask, and the sample is just that small little bit that you actually want to get. The census is getting data from every member. These questions happen a lot. So they ask 410 human resource professionals. The population is all of them. The sample is just the 410. This is stuff about preparing the data, analyzing the data. Obviously, you can read these more in depth. Source of data. Okay, sampling method is stuff that people seem to mess up. So that could be a good place to start us thinking about things. So if I click this on the side, it like shortens it. So I have a little bit more space. So I'm going to pull this here. I'm going to pull this up, and there's my Pearson book right here. So some things about something that's bad. Self-selected sample or voluntary samples, not the best because you're not getting like the full population. So if it's an internet poll, people decide, a mail-in poll, they could be problematic. There should be other ways to get your data. They've got examples here that we can analyze. Okay, so another idea, statistical significance. So basically statistical significance, like something that we're always going to look at is what's called our alpha level. And this gets confused a lot. So alpha level, it's usually at 0.05 for like human, like social studies or psychology, like social sciences and stuff. If it's the medical field, it'll be like a 0.01. What does that mean? That means 95% it's not due to chance. We are 95% certain at this alpha level that this was not due to chance, and we can reject something called the null hypothesis. So the HO is usually what's our null hypothesis. And what does that mean? It basically means there's no change. It means that the means, and this is a symbol for mean. How do we get that word mean? Um, Actually, the word mean helped us win the Peloponnesian War, which is where we get it from. So the Greeks were able to count how many bricks there were uh, around their building and would, oh, sorry, that was mode. Mean was actually, oh, God, there's lots of statisticians that use mean. I'll get into it another time, but mean is just the one that's the average, it's the average amount. That just means there's no change between mean one and mean two. And then H1 or HA is all alternative hypothesis. And our whole goal is that this mean is different. So I kind of wrote that wrong. Guess what? We all make mistakes, right? Sorry, it's a little early, but here we go. So the null hypothesis means there's no difference in the means. So that means your first mean, your mean one, the average of something, and your second average are exactly the same. There's no change. So like whatever you're experimenting, your control group, your experimental group, there's no difference in them. Your alternative hypothesis means what? That these means are not equal. Now, right here, this is what's called the two-tailed hypothesis because we don't know if it's going to be, this is going to be bigger or this is going to be bigger. We just know that's different. Now, if we claim before our study started that mean one was bigger than mean two, this is two-tailed. Could go both ways in our study, which makes the numbers a little different. And this is our one-tailed. You could have the one-tailed going the other way too. And we could say that mean one is less than mean two. But all this means statistical significance. Now, that might not be practical. Like we're just saying that the significance is a likelihood that's not occurring by chance. So an outcome can be statistically significant or may not be important, which is important, but it might have practical significance. So it's possible that common sense doesn't, so a treatment could be good, but it could not be good enough to justify its use besides practical. And I would read these examples that just show that statistical significance just means that the numbers make sense, that there's a difference. And we're 95% sure that that difference exists. We have to be 99% sure in like a medical situation. But that might not be practical. Like it might not help us on our day to day. That's the main difference between those words. All right. Loaded questions. Lots of bias, I'm sure. Okay, so one of the biggest ones is a non-response. A good example is that it's, let's say we sent 1,000 surveys out to people about a book of an author that we thought was interesting. And we only got 12 of them back. That just means that even if it's significant, those 12 people, they are so different from the population. They're so different that we can't really use that data. There's bias here. So this is what's called non-response. All right. I'm going to keep it going. Or low response rates. This is like nobody's responding. This is like a low response rate. Okay. Percentages. This is going to be probably the biggest thing that we're going to look at. So percent, this word, percent, it's going to come up a million times. So think about miles per hour, points per game, words per minute, words per minute. Figure out how fast you're driving. You take your miles and you divide it by the hours. So per just means the fancy word for divide. And cent, think about how many cents in a dollar, how many years in a century, how many legs on a centipede, they're all 100. So that's why the percent symbol literally means to divide by 100. That's what this word is telling you to do, divide by 100. We can move the decimal, but this is really going to help us out. So if they have the symbol there, 5%, this means it's 5 divided by 100. That's what that symbol is telling you to do, which means what? We can actually divide it. 5 is it's on the top, so it goes inside. I can't put 100 into that, so I put a decimal here, decimal, which is like a part. 150 doesn't go, 0. 100 to 500 is 0.05. If you wanted a simplified fraction, we could divide them both by 5, and that's going to be 1 out of 20. They all mean the same thing. Now, if we want to add a percentage to something, if we want to add the percentage, that means we have to multiply it by 100. So if we want to see what 0.5 is, and they're asking you to write that as a percentage, we want to add the percentage in, then I have to take 0.5 and times it by 100. Timesing by 100, I mean, decimals are weird. So this looks strange. So if I just pretend it doesn't exist, 5 times 100. 5 times 0 is 0. 5 times 0 is 0. 5 times 1 is 500. Then all we have to do is count the decimals. This is 1 decimal place. That's 1 decimal place. So 0.5 as a percentage is 50%. I'll be going over percents more, but that was a little quick intro. If you ever want to think about a percentage, I always suggest drawing it, no matter what it is. So let's say it's 3/5. You're not sure what that means. Think about a pi. 1, 2, 3, 4, 5. And you could always estimate. So this means this much is filled, 3/5. All right, so it's more than half, right? So if we were to divide this, we better get a number that's bigger than 0.5. So let's figure this out as a percentage. Well, first I have to turn this into a decimal. So the 3 goes here, the 5 goes here. Can I put a 5 into a 3? Nope. Can I put a 5 into a 30? 6 times, so it's 0.6, a little bit more than half. To make it a percentage, I have to multiply it by 100. 6 times 100 is how much? 600. And I have how many decimals? I've got 1 decimal place, so my answer gets 1. So 3/5 is really how much percent? 60%, and it should look right. I'm a really big fan of drawing your visuals. It'll help you out a ton. All right. Ooh, we get some. I like that. 6% of. Okay. This crazy word of. Of always means multiply. In math, the word of every time, no matter how many times I tell you, of means multiply. So every time you get this. So when they say 6% of 1200, this means 6 divided by 100 times 1200. Now we can cheat. You ready? This is a fraction. I know it doesn't show it here, so I'll do a trick for you. So make this a fraction by dividing it by 1. We go top times top, bottom times bottom. But if they've got zeros, we can cross them out. So this is 6. So this is 7, 2, 0, 0. And we're dividing this by 1, 0, 0. The zeros cancel, and you're left with the 72. How would I do it? Zeros on the bottom, zeros on the top. What's 6 times 12? Well, 6 times 10 is 60. It's just 6 times 12. I literally just think 6 times 10 is 60. 6 times, this is how I'm doing them in my head. Oh, sorry about that. 6 times 2 is 12, and I add them together. That's how I knew they were right with the 72. All right. Decimals to percentages. If you want to move it back and forth, the first thing I would do, you want to add the percentage in, times it by the 100. And the fractions are telling you to divide. It's kind of what I was showing before, which is kind of cool. But it is what it is. They all mean the same thing. They all mean the same thing. A decimal can be a percent can be a decimal. You can think about how it works. A fraction, they give you 3/4, right? This is the one they want. It's just a division sign. Fraction or fractus just means broken. So it's just broken into pieces. So 3/4 can just divide. 3 goes into 4. How many times? That's why the symbol tells you, and in math, the symbol will kind of always tell you what to do. You get a little crazy, but it usually just tells you what to do. 4 can't go into 3. 4 goes into 37 times. That's 28. Four goes, oh, I got the decimal. I can bring down as many happy zeros as I want. Four goes into 25 times, 0.75. And then to add the percentage, we times it by 100, or you can just move the decimal. Uno, dos, 75 magical percent. All right. Oh, okay. So I guess that's the end. It's time for some problems. So I'll do the first few. I'll do, how many do we have here? 1 through 3, 6, 21, 24, 37, 38, 40, 41. Let's just start with the first one. And the answer should be in the back. But let's just look at number one. Let's see what it says. All right. Oops. In an AOL survey of internet users, this question was posted online. Have you ever been hit by a computer virus? 170,063 responded, 63% answered yes. What term is best to describe this type of survey, which consists of those who chose to respond? Oh, so it's the first one. It's either called self-selected or voluntary. And if you're wrong, that's okay. You could always just give me a reason why you think that and why is this bad. It doesn't get the whole population. Does not account for the whole population. It's just for people who are like, oh, this matters to me. So this could be higher than usual. All right, let's go to two. Numero dos. Oh, sorry about that. It's not letting me click. There we go. Here we go. Numero dos. Here's number two. All right. In a survey of 1,046 adults by Bradley Corp, subjects were asked how often they wash their hands when using. Okay. The sample in the population. Obviously, the problem is people want to seem good, so that's the bias that's here. That's what B. So I would just watch the people because these people are lying to seem good. That's what B is. But A, the sample's a small group. So the sample is always the number. So that's 1,046 adults. And then the population, they're trying to get all adults that's who they want. They want all adults. Simple as that. All right, we can look at number three. When testing a new treatment, what is the difference between statistical significance and practical significance? Can a treatment have? Yes. So this answer is yes. It can be different, but what is the main difference between these two things? The stats, you can just think about it as the numbers. Like the numbers are saying this is a 95% chance, 95% confident. We're 95% confident that this is not due to chance. And practical, you can think about it as like a real world situation. And yes, it could be minusculely better and then numerically, but like it doesn't really matter to the world. Let's see where we're at. Oh, sorry, I'm just looking for the numbers. Next one we have to do is 6. And extras 5 through 8 determine whether the given source has a potential to create bias in a study. All right, let's see how good this study is for 6, and then we go all the way to 21. I'm not going to do them all, but we'll see how many I knock out right now. Then I'll go to the next group. Body data in Appendix B includes pulse rates of subjects, and those pulse rates were recorded by examiners as part of a study conducted by the National Center for Health Sciences. Whether the given source has potential. Okay, so we got to go to Appendix B. I'm going to actually look at the numbers. I can't really make a decision without it. So I guess I got to find Appendix B. Let's see what it says. Sorry, I can't see. Put this here. Here's Appendix A. Are we finding? I don't see Appendix B. Oh, here it is. Okay, so Appendix B. I already don't remember what it was, so I'm gonna go back. We're in 1.1. So, data set one, body data. Data set one, body data. Okay, let's find data set one, body data. Data set one, body data. All right, let's see what it says. We can decide. This appendix lists the first 5 rows of each data set. The complete data is available for download and trial stats, including Excel. I'd use Excel. I like Excel, but you use whatever you want. Let's see what it actually happens when I download this data. I don't really know where they got it from. I don't know how it was done. They don't really tell me the methods. They just say that it was done. Maybe there's more information here, but I already am not like the biggest fan of this question. You could always tell me the question's kind of bogus. All right, let's find it. All right, so they got the age, the BMI, which stands for body mass index. Okay. We got our pulse, our systolic and diastolic, HDL, LDL, white blood count, red blood count, platelet count. I don't really see bias here. I wish I knew how it was. I'm going to say cannot answer without methods. That's what I would say. But you can give me whatever answer you feel like makes the most sense. I'm pretty sure 21 was next. And I'm pretty sure all the odd ones are in the back of the book. So keep that in mind. If I made a mistake, guess what? We all make mistakes. And feel free to call me out. Shoot me an email or post it. Be like, you messed this one up. Definitely let me know if I'm missing some. So, we're all human. I'm just trying to give you like some good information and teach you the best I can virtually. All right, so we're at 1.1, number 21. Here we go. All right, so we got some data. So refer to the sample of the body temperatures, degrees Fahrenheit in the table below. The body temperatures are from data set 5, appendix B. Okay, so this is 8 a.m. to 12 a.m. So morning till noon, 97 degrees, 98, 97, 97, 98. And then well, this one went down. So up, down, up, up, down. Not getting a lot of info, but let's figure it out. So refer to the table body temperatures. There's some meaningful way in, oops, sorry. There's some meaningful way in which each body temperature recorded 8 a.m. matched with the 12 a.m. temperature. I believe so. I believe that they're very similar. They're all within about 1 degree of each other or less than 1 degree. So that's what I would say. I think each body temperature is matched. Oh, so never mind. This is what they want to know. Basically that it's matched with the same subject. So that's what they want to know. These are matched by the same subject. Matched per subject. And you can see they're very similar. They're all within 1 degree, which makes sense. It's one human, right? All right, what other questions do we got? I'll do maybe a couple more. 22, 23, and 24. Okay. The listed body temperatures were obtained by Dr. Stephen Wasserman, Dr. Philip Makiewicz, Dr. Myron Levine, who were researchers at the University of Maryland. Is this source of data likely to be biased? We probably should say no because it's the University of Maryland. I think it's an R1 institution. We can look up the credentials of them. Are they R1? Are they R2? I went to an R1 university, so it was kind of big. Oh, they are. So they have R1 status, which means they're like one of the most highly regarded universities. I think everybody wants to be an R1 university. So yes, I would say yes because it's an R1. I didn't do a lot of research there. So 22, yes, because it is an R1 university. 23. Given the body temperatures in this table, what issue can be addressed by conducting a statistical analysis of the data? Ah, we could do a t-test and compare them. We only have 5 samples, though. I would say that this isn't enough data. I say we do not have enough data to make that call. That is my opinion. We can say that as the day rises, that the temperatures seem to go up. To me, that's not a uh, oh, it's just asking what could be addressed. So what issue can we address? We can do a study and be like, does the temperature rise throughout the day? That's a good research question. And how will we do that? Well, our null hypothesis. I keep using this word null hypothesis. What does that mean? The null hypothesis would be there's no difference in means. And our goal is to reject that. We always want to reject the null. So this would be the mean of 8 a.m. will be the same as the mean from 12 a.m. And then our, oops, sorry about that, my little pad. And then the other thing we're going to say, our alternative hypothesis we can find is basically the main question we want to know is, does the temperature change? And how do we say this? Here, sorry, I will try. I'm actually going to type this. I'm definitely going to type this one. So the research question we would want to answer for this. Um, there a significant change in body temperature from 8 a.m. to 12 a.m. Ta-da. All right. I'll do one more. Hopefully this is useful for you. Oh, we get 24. Okay, here we go. So maybe this will be better. I'll leave the last couple for you. But here's 24. Let's see what it says about conclusion. And just let me know if you'd rather me type it. Most of them is going to be numbers. So I have to write it, but I'll type if my handwriting is that atrocious. We analyzed the list of body temperatures with suitable methods of statistics. I guess we don't know them yet, but this would most likely, since it's the same person, it would be called an independent samples t-test. Independent would be we're comparing them to themselves. It would not be a two sample because it's the same people over and over again. If it's only at two times throughout the day, and I'll go through the different types of t-tests if you want, but I would refer to um, that thing that I made that has all the different types of statistical analysis, but you're doing a t-test. Uh, t-test is basically we're evaluating means, and we could actually run this. We can run it on Excel, we can run it on the StatCrunch, we can run it on whatever we want. So if we analyze the list of body temperatures with suitable methods of statistics, we conclude that when the differences are found between 8 a.m. and 12 a.m., there's a 64% chance that the differences can be explained by random results obtained from populations that have the same 8 a.m. and 12 a.m. What should we conclude about the statistical significance of those differences? We're saying 64% it's due to chance, it's due to randomness. That's not good. 64%, not enough. And it's for random. So that means we're only accounting, we can take 100 and minus 64. So we're saying that, and I could see that some go up and some go down here. So ready? So that would be 6, 36. So it's only 36% likely it is due the change. Sorry, not it. The temperature change. Sorry, the body temperature change. is due to the time of day. Now, because this isn't a medical thing, which should be all medical studies should be 99% or 1% due to randomness. Ours is like a social experiment, kind of like we're not testing a drug. So this has to be 5%, 5% due to chance. So we can't, so this, in this case, statistically speaking, we would do what? We would accept the null hypothesis, which means what? Accepting the null means there is no difference between mean 1, which is our 8 a.m. mean, and mean 2, which are our 12 a.m. The means are too similar. The averages are too similar. So we can't say that they're different just based on the time of day. I think that's a good place to end for the first one. Good luck on few I left you to try. The last few, 37 through 41. If you still can't do them, read it, watch the videos. But hopefully this was a good start. I'll be making more. Yeah, I'll probably make a couple today. I'll just make them every day. So I'll be making them every day. I'll knock out tons of these. So just let me know if they're helpful or how they can be better. And enjoy your morning.